Hello students, on the screen we have spheres, cones, cubes and cuboids. Yes, we're going to learn how to solve the problems involving volume and surface area of pyramids, cones and spheres. Do get ready your worksheet and let's get started. First question, we asked to find the volume of the pyramid. The unit of measurement given is in centimeter. So the formula to find the area of the pyramid equals to 1/3 times the base area times the height. So what is the base area? The base area refers to this shaded for you. This is the base area. And what represents the height? Height is represented by this, the vertical height. It's the vertical height. All right, so with all this information, we can find the volume of the pyramid easily. Right, since the base is a rectangle, the area of a rectangle will be length times breadth. Then multiply by the height, which is given to be 13. And with all this, you can just use the calculator to evaluate the answer. And the answer is the 1456. And since we're finding volume, the units would be centimeter cube. Why centimeter cube? Because if you look at the formula here, 21 is the length of the base, which is in centimeter. 16 is the breadth of the base, also in centimeter. 13 is the height, also measured in centimeter. So we have centimeter times centimeter times centimeter. That gives you centimeter cube. So that explains why the unit for volume is centimeter cube. Right, let's look at the next question. I have skipped exercise 10.1 question 10 because that question is the hardest of all. So I've left it, I leave it as the last two slides. So let's look at question 3 first, which is exercise 10.1 question 11. All right, so you're given a cuboid, and inside a cuboid, we're going to remove a pyramid. Okay, and then we're asked to find the volumes of the remaining solid. So all we need to do is just to find the volumes of the cuboid, which is base length times breadth times height. So it's 24 times 13 times 30, give you 6240. And then find the volume of the pyramid, which is 1/3 times base area times height. Now in this case here, you see that the height of the pyramid is the same as the height of your cuboid, which is 30. Okay. Right. So to find the remaining solid, you just use the volume of the cuboid minus away volume of the pyramid. So that gives you 3120 centimeter cube. Right, let's look at the next question from exercise 10.2. This case here, we are solving problem involving volume of a cone. So the formula to find volume of a cone would be it's still 1/3, except that if you look at the cone carefully, the base is a circle. So the area of a circle, how do you find area of a circle? Yes, it's pi r squared. Okay, so area of a circle is equals to pi r squared. So here the volume of a cone will be 1/3 times pi r squared times height. Right, so it's almost the same as the formula for pyramid, except that for pyramid, sometimes it's a rectangular base, sometimes it's a square base. Sometimes it can be a hexagon or pentagon, okay, shapes of a polygon. For a cone, it's always a circle. So area of a circle is pi r squared. So this is 1/3 times pi r squared times height. So for part I, that will gives you 1/3 times pi. The radius is given to be 16. The height is given to be 30, and you can just use a calculator to work this out. That gives you 8042.477. Express the three significant figure, look at the fourth number, which is 2. So that is less than 5, so we replace it with 0. So that's 8040 centimeter cube. All right, that's part I. So total surface area, okay. The keywords to look out for is a closed cone. If it's a closed cone, means there's a cover. Okay, there is this cover. It's not like those ice cream cone where it is open. In this case here, there's a cover. So the total surface area would refer to the area of your cone, the curved surface area of the cone. Will refer to the curved surface area of the cone plus the area of the base circle. So the curved surface area of the cone, the formula is called pi RL. Pi RL. So what is L? L refer to this slant height here. This is your L. This one is the slant edge, not height, sorry, it's called the slant edge. And that is the letter L in the formula pi RL, the L. Right, then plus the area of the base, which is a circle, so pi r squared. So what we need to do is to find the L. So to find the L, we will have to use Pythagoras theorem. If you look at this triangle here, it's 90 here. Okay, so if you were to use Pythagoras theorem, c squared is equals to a squared plus b squared. So c is the, you put the arrow there, is the side that's opposite your right angle triangle, the longer side. So it's L squared equals to 16 squared plus 30 squared. 16 squared plus 30 squared will give you 1156. So L will be square root of 1156. It gives you exactly 34. Right, so with that, we can just plug inside here. That will be pi times 16 times 34 plus pi times 16 squared. And you can just use a calculator to work out the value. Right, so that gives you 2513.27. The three significant figure, look at the number 3 less than 5, so we replace it with 0. So it's 2510 centimeter squared, since you're finding area. Right, let's look at this question from exercise 10.2 question 4. Right, so this one, the diagram is not given to you, so we will have to draw your own diagram. We are given a solid cone. Again, a solid cone means it's a solid cone you can consider as a closed cone. So you're given the base area to be 36 pi. So basically the base is a circle, so area of the circle is equals to 36 pi. And then you're given the volume of cone to be 108 pi. So you asked to find the height. So this is the question mark. So we're going to let the height be h. Right, so to find the height, we just have to make use of the volume of the cone, because it's only to find volume of the cone, the formula is 1/3 times base area times height, right? Only the volume has the height there. So you will have to use this to find. And this is 1/3 times pi times r squared times height. Okay, and then you can cancel. Okay, then we have a problem here, because can you see that we have two unknowns here? Your radius is unknown, your height is unknown. You can't solve an equation with two unknowns. So therefore, we need to find the radius first. So to find the radius, we have to use the area of the circle. Okay, so area of circle, you're given to be 36 pi. Then the formula to find area of the circle is pi r squared. So pi r squared is equals to 36 pi. Cancel away the pi. So r with square root 36 give you 6 centimeters. So you need to find the radius first. So with this radius, I can plug inside here. Okay, so that will be 1/3 times 6 squared times h equals to 108. You can use a calculator to work that out, which give you 12. So 12 h is equals to 108. You divide by 12 on both sides. Divide by 12 on both sides. So 108 divided by 12. That gives you 9. So your height is 9 centimeters. All right. So part B, slant height. So the height and the slant height are two different things. Oh, the slant height is actually the okay. So I used it wrongly just now. Not just now. In the previous slide, I call it slant h. Is slant height. So the slant height refer to this. This is your slant height. This one is your slant height. So to find the slant height, you will need to use Pythagoras theorem. Okay, because the height we found it to be 9 centimeters. This is 9 centimeters. Then the radius we found it to be 6 centimeters. Okay, so let's let the slant height be L. So c squared is equals to a squared plus b squared for Pythagoras theorem. So you're going to replace the letter c with L. So L squared is equals to a can be 6 squared, b can be 9. So L squared is 6 squared plus 9 squared. 117. So L will be square root 117. Which is approximately, leave it to 4 significant figure. Only final answer, then 3 significant figure. So final answer will be 10.8 centimeter. Okay, so that is your slant height. That's for part B. All right, so total surface area would just be area of your curved surface area of the cone plus your base, which is a circle. Right. So part C, total surface area, curved surface area of cone plus area of circle, area of base circle. So curved surface area of cone, if you were to recall, is pi r L. Then area of a circle is pi r squared. So that gives you pi times 6 times 10.82 plus pi times 6 squared. So you work out a figure on your own, express it to 3 significant figure, you should get 317 centimeter squared. Right, let's look at the next question. So in these questions, we're given a conical vessel. So it's filled with sand. Right. So for the first part is asked to, you're not given the radius, you're given the height to be 7, you're given the volume to be 320 centimeter cube, but we're not given the radius, which is what we're supposed to find in part A. So the radius be r, and we also not given the slant height, so let's call it L. All right, so how do you know 320 it's the volume? If you look at the unit, it's cm cube. You look at the cube there, it refers to volume. So volume of the cone will be 1/3 times pi r squared times height. Right, since we don't know the radius, the value for the r is unknown, we can rearrange your 1/3 pi and 7 so that you can use a calculator to evaluate it to be 7.330 times r squared equals to 320. You divide both sides by 7.33. So you have r squared equals to 43.656. Have more decimal places, your answer will be more accurate. It's only final answer, then 3 significant figure. So you need to square root your 43.656. You get 6.6072. You look at the fourth figure, which is 7, carry 1 to 0, so 6.61 centimeter. That is the answer for the radius. So for part B, you asked to find the surface area of the vessel in contact with the sand. So basically, it's just the curved surface area of your cone. And to find the curved surface area of the cone, the formula is pi r L. So I need the values for L, for your slant height. So we can use Pythagoras theorem. This one is similar to the earlier concept we have learned. Using Pythagoras theorem, find the slant height to be 9.626. Plug into your formula, pi r L, you'll get 199.8. Look at the number 8, more than 5, carry 1 to 9, and then carry 1 to 9, again carry 1 to 1, become 200 centimeters square for area. Right, let's look at exercise 10.2 question 9. So in exercise 10.2 question 9, what this question is all about is you have a metal cone, and then you melt it, and when you melt it, you put it in a mold to form a sphere. Okay, so you're asked to find the radius of the sphere. All right, so in this case here, we are comparing volume. Okay, we're comparing volume. So that's the concept here. Okay, so the formula to find volume of a cone is 1/3 times pi r squared times height. So the volume of the cone will be equals to your volume of the sphere, which is 4/3 pi r cubed. Now, this radius and this radius are not the same. So if you write like that, right, it's very confusing. Okay, so I would advise you to do it separately as you find the volume here, volume of the cone first, which is 1/3 times pi times 8 squared times 13.5. Okay, so that will gives you, you can just leave the pi alone. I'll explain to you why, because you're going to equate both volume, right? So in the end, you can just cancel off your pi. Okay, and then the volume of your sphere will just be 4/3 pi r cubed, because we don't know the radius. Okay, so we're going to equate these two volumes, because the volume is the same, just that the shape is different, the area is different. Okay, the surface area is different, the shape is different, but volume remains the same. All right, so we have 4/3 pi r cubed equals to 288 pi. Okay, just cancel away this pi like that. So you have r cubed, divide both sides by 4/3. So 288 divided by 4/3. You use your calculator to work it out. You have 216. So cube root 216, you have 6. So the radius is 6 centimeter. That's part A. Then part B, surface area of the sphere. Okay, the formula to find that will just be 4 pi r squared. So since we found your radius already, which is 6, you'll get 24 times pi, not 24, 4 times pi times 6 squared. So that gives you 452.389 to 3 significant figure. Look at the number 3, less than 5, so just throw it away. So 452 centimeter squared for area. Right, let's look at the next question. The next question consists of a capsule. It consists of a cylinder. So this is a cylinder. Right, and the both ends are hemispherical. Hemispherical, it's half of a sphere. If you take the sphere as like a watermelon, and then you just chop it in the middle, must right in the middle into 2 equal half. So it will be called hemisphere. So two of them, two hemisphere, you will combine them. You can just add them together and it will become a sphere. Okay, so half of a sphere is called a hemisphere. Hemi means half. Okay, right, so we asked to find the volume of the capsule. So the volume of the capsule will just be the volume of the cylinder, which I've given you the formula here. So these are some formulas you need to remember. In the GCE O level or N level exam, the only formulas that's not given to you will be these two not given to you. You won't be told not given in the exam, okay? Volume of a cylinder and curved surface over a cylinder. I'm not too sure why. So anyway, so volume of the capsules will comprise of volume of the cylinder plus, because just now we mentioned that the two hemisphere will add up to become a sphere, right? So plus volume of sphere. Okay, so that will gives you volume of cylinder is pi squared times h. So your radius, you're given diameter to be 7. So radius will be 7 divided by diameter divided by 2. So square it. Make sure you bracket. Or if you find it confusing like that, I would just advise you take 7 divided by 2 gives you 3.5. So 3.5 squared times the height. It's okay. Just be careful. The height is not 20. All right. Okay, 20 is from one end to the other. So you need to, the height of the cylinder is just from here to here, which means you have to minus away the radius of your sphere is 3.5. So you will have to take 20 minus 3.5 times 2. So it's 20 minus 7. 20 minus 7 is 13. So it's pi times 3.5 squared times 13. Then plus volume of the sphere. They've given you the formula here, 4/3 pi r cube. So 4/3 times pi, radius is 3.5 cube. So you just use a calculator to work that out. So that gives you 679.893 expressed to three significant figure. We'll look at this number here. So carry 1 to 9, so becomes 680 millimeter cube. Okay, you're dealing with volume, so it's millimeter, so it's cube. Right, so that's part A. So for part B, to find total surface area, so that is equals to the area of the sphere, okay, because the two hemispheres will join to become the sphere, plus the curved surface area of your cylinder. So the curved surface area refer to this part here. So when you open up, you know, this is how a cylinder is like a container, right? When you open up, it actually can form a rectangle, okay? Where this circle, the circumference will become the length of your rectangle. So to find circumference of a circle, it's 2 pi r. And this is your height. So that explains this formula, curved surface area of a cylinder. That explains why is it called 2 pi r h. Okay, so area of a sphere is 4 pi, radius is 3.5 squared. and then curved surface area is 2 times pi, radius is 3.5, then times your height. Just now we calculated it to be 13. So just use a calculator to work out this. And that gives you 439.82. So to trace a significant figure will be 440 millimeter squared. Let's look at the next question. In these questions, we're given a right pyramid with a rectangular base. So some of you may be wondering what is the meaning of a right pyramid. What is not a right pyramid? Not a right pyramid is called an oblique pyramid. So what's the difference between oblique and right? If you look at the vertex point, this is called the vertex point. It's the sharp point there. If you were to draw a vertical line from the vertex point all the way down and touch the base, you'll see that in a right pyramid, this vertex point is directly above the center of your base. That's a right pyramid. Whereas for a oblique pyramid, if you were to draw a vertical line down, this point here, this point here, you see that point is not the center point of your base. So that's the difference between oblique and right. So in most of the problem sums that we are dealing with, we are only doing right pyramids. The next questions you may have to take note of is this thing called rectangular base. What's the difference between a rectangular base versus a square base? If you have a square base with all the four sides equal, then you would have all the four triangles identical to each other. If it's a rectangular base, it's a different story. Because for a rectangular base, the length is not the same as the breadth. Here the length is 22 and the breadth is 18. So when that happens, then you see that the one highlighted in green, the two triangles are identical, are similar. So they have the same slant height. And for the other one, the one highlighted in blue, the two triangles are similar to each other. That's the reason in part B, you are asked to find slant heights, because there will be two different slant height. All right, let's do part A. So for part A, finding volume of the pyramid, this is not difficult. So the formula is 1/3 times base area times height. So here our base is a rectangle, so it's 22 times 18. Our vertical height is given to be 23. And that gives us 3036 centimeter cube. So this is the first part. The next thing is that we have to find the slant height. So since there are two different triangles, two sets of triangles we have to find, let's focus on the first one here, the one highlighted in green. So this would be my slant height. So I'm going to form a right angle triangle here. So this is 90 here. So from here to here will be half of 22, because 22 it's all the way from here to here. So half of it will be 11. Okay, and then the vertical height is 23. So we can use Pythagoras theorem to find our slant height. So I'm going to call this slant height H1. Okay, H1. So Pythagoras theorem, it's C squared equals to A squared plus B squared. So the value for C, it's the one opposite the 90 degrees, the longer side, so which is our H1. So I'm just replacing the letter C with H1 squared. And you can take 11 as a value for A and 23 as a value for B. And you can use your calculator to work out 11 squared plus 23 squared to be 650. And we need to square root it because we are finding H1. So H1 squared is 650. So therefore, H1 is the square root of 650. And that gives you 25.495. To three significant figure, you look at the, if it's three significant figure, you look at the fourth number. So the fourth number is 9, carry 1 to 4. So it's 25.5. And since we're finding height, the unit is in centimeter. So that is our H1. All right, so just now we mentioned also there's the other triangle. There's another set of triangle that has the same slant height. And this is the one we're talking about. Okay, so this is our slant height. So if you look at the triangle, it's like that. Okay, so this will be half of 18, which is 9. Okay, so I'm going to call this slant height H2. Right. Similarly, we're going to use the Pythagoras theorem. So H2 squared is equals to 9 squared plus 23 squared. So if you use a calculator to work this out, it will give you 610. So H2 will be square root 610. Gives you 24.698. And again, expressed to three significant figure, look at the fourth number, carry 1 to 6, so it's 24.7 centimeters. So these are the two slant heights. Let's look at 2C. So for 2C, we asked to find the total surface area. So the total surface area will comprise of the area. Okay, we have already found the two slant heights for the triangles, right? We will need that to find the area of the triangle. So total surface area will comprise of the area of the base rectangle, which is length times breadth, 22 times 18, 396. The area of the two triangles with the base length 18, half times 18 times 25.495, then times 2, because two similar one, as explained earlier on, and then the other two, and total surface area, you add up these three numbers. So that will give you 1398.266. So to put it to three significant figures, you look at three significant figures, 3. That means you look at the fourth guy here. this is first, second, third, fourth. So the fourth is the number 8. So 8 is more than 5, so we carry 1 to 9, and then that becomes 0, right? And then carry 1 to 3, so that becomes 1400 centimeters squared.